Hello. Check it out. This coffee is made with 10 days expired cream. It's fine. Okay, so today my plan is to document my intended architecture for the Roblox Dom Strom project and then kind of just stop working on it because I want to work on other stuff. Um, I I might get back into it right now today, but I want to at least document my thoughts so that if I try to pick it up again, I have I, I know what I was thinking all those years ago. I was looking at these guys' library. This library is very ad hoc, and like the requirements are constantly changing. The code is pretty messy, but they did what no one else did, so it's pretty cool. Vulkan Video. They changed the name to GPU Video, which it's kind of a scam. Okay, I go here. Me. This guy. Yeah. Okay. Uh, we say binary strong. All right. Is this like AI type stuff? Oh, gross. Bruh, search. Three months ago. Okay, it's not an AI thing. Let's see. All right, I'm just gonna go for it. Let's see. Okay, where's the thingy? Okay. Uh. Parallel decoding architecture. First step of parallel decoding is parse chunks sequentially. For real? Is that here? Yeah. Uh. Uh. Bruh, let me do it. Call parse chunks. Which returns that. So why do we want to do this? This sets us up for parallel chunk decompression. Okay, number 15. Oh, what happened? Hello? Hello? Unlucky. 2. Decompress all chunks, all chunks in parallel. Three. Meta. Parse. It's like put them into these different variables. Label chunks. Categorize chunks. Chunks are categorized into it sounds like freaking like Sonic music. All right. Oof. Who called this function? Who did this? Huh? Oh, it's mod. Dot finish. Okay, so categorize chunks. Chunks are categorized into blah blah, and pasted into local variables. Parse header. Chunk headers sequentially. Okay. Categorize chunks. Yes. Uh, construct instance map. Type infos from inst chunks. Uh, 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 inst chunks are. I guess we can do parallel, huh? Decoded in parallel and assembled into type infos hash map. Uh, um, okay. Uh, decode non-parallelizable chunks. Uh, construct class property chunks from prop chunks in parallel. Prop chunks are header is parsed, and then the parser decides whether to decode the chunk or and yeah, so the prop chunk header is parsed. Some property types can be okay. Yeah, the chunk layout of some property types can be known ahead of time without requiring sequential decoding. These chunks decoding complete decoding of these chunks is deferred to the finish step. Stage. Per instance parallelism finish stage. Most property types such as string must be decoded serially because the position of each string within the file depends on the length of the previous string. And the lengths are not well, honestly, when no, it's just kind of fine, isn't it? Hmm. Uh, Wait a minute. Well, string is a particular one because like it's really easy. The first step of like jumping through the string lengths, you can just skip each string. You don't have to allocate each one. Um, Such as C frame. Uh, each value is not known before decoding the previous value. These are decoded with per chunk parallelism right now. Cool. There we go. Okay. Great. Parallel state is ready. Okay. So now per instance parallelism. No way. How did he do that? Okay, so it's like kind of really complicated. Oh wait. Right. I should document the stuff. Um. Yeah. So this is like. Uh oh. Class property chunk. You what? Is constructed using into property chunk state trait. Well, no, there's another trait, right? So there's this into Bababibu trait state, but we have class property chunk new. Yeah, no, that's not right. New which matches the class calls the appropriate class chunk constructor. The class chunk constructor, such as part property chunk new, matches the property name and infers the expected property type. Oh, but it actually contains the property type, doesn't it? Matches the property name and the okay, well, this is clearly missing from the decoder. The file format describes the type, if I am not mistaken. Gabagoo. What are you doing? Decode prop chunk. So look, binary type byte. Bop 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 bop. Huh? Return okay. You what?
Oh my god, bro.
Oh my god, bruh. This leads us to believe is so sad. You should really be able to ask Roblox. Alright, try into type. No way. The class chunk constructor matches the property name and type. The provided binary type. The provided by the prop and infers which which decoder should be used. This is essentially multiplexing new. With the T inferred by the destination variant of part property chunk. Okay. Uh, the what is it called? Freaking class property chunk. The class property chunk is inserted into class property chunks with the try push method. Each wow. Okay. So then parallel state finish. Um uh a massive chain of parallel iterators is constructed. Tree nested nest structure using generated code. Run with per instance parallelism. Maybe like everything is this. Alright, I can try like this. Oh my god, bro. Okay. So how does it work? So uh uh each field of class property chunks has its own implementation of into parallel iterator, which yields I before E items of that class. For example, part property chunks into par iter yields excuse me. Oh snap. I guess it's not actually done. Yields classes part. Um, uh, the instances are converted into the strong instance type. Wait. Is that instance? I'm trolling. My goodness gravy. Yeah. Yeah. And our boxed up into the strong class type. RBX dom strong library types. Hello, mod class. Am I trolling? Oh, there we go. Instance. Am I troll? Okay, wait. You what? Instance? Don't we need the instance freaking new situation? Oh, instance builder real class C. C. You just smack it. IZ, and then in order to how into class, C into class. Properties. Flow into strong instance builder. Wayment. That doesn't work. I know everything about every instance already. I can pre-calculate this data and use a shared reference, or like calculate it ahead of time. I can turn the whole thing on its head. Ayya. Okay, why don't I go ultimately, are ultimately converted into, RBX dom strong instance, and then each, class instances of each class are chained together into a fantastically large iterator. We're on step 1, man. Okay, hello. Each field of has own implementation of each interparallel iterator which yields items that class. Part. Yeah, I don't know if we need steps here. The instance properties are ultimately converted into strong instance and then instance of each class. Chained together iterators. Chained together into a fantastically large iterator, which is collected into the strong DOM in parallel. Fantastic. This is what I know. How did he do? That is not easy to parse. Why don't I? Yeah, I think this. We can have like headers. All right. Construct. How did he do that? Uh, uh, Decoding class property chunk. Game. Uh, don't do that. Bruh. Why is it different? Why? Why? Maybe, I mean, maybe it's okay to just do this. All right, why don't I add some freaking goobs to this? Finish. Gotcha. Yeah. Can I put this here? Can I go like this? Yeah. If you put too many, it gets a little bit gooby though. Okay, yeah, like this is, it's using this function. We're highlighting the important part. What function is called? Class property chunk is constructed using. Okay, fix posture. Uh, uh, each field of part property chunks so loud, man. Represents property of part. A property, a slice. It's a list. Uh, and each one all of the each property chunk T has its own implementation of into parallel iterator. For example, property chunk yields C-frame. C-frame. Given the field this C-frame dot into parallel iterator part property chunks dot cframe into parallel iterator yields cframe. Given the field bing bong, part property chunks class property chunks dot part snake. How does that look? How about this? Each field of class property chunks has its own implemented iterator yields items in that class. Okay, into parallel iterator, which yields values of that property. Then instance iterators of each class are chained together into a fantastically large iterator. Strong DOM in parallel. Very nice. Each field of class property chunks has its own implementation of into parallel iterator, which yields items of that class. Given the field each field of part property chunks represents a property of a part. Oh, is this saying where my cursor is? It's not some like weird formatting thing? Okay, that's nice. I was a little bit confused. Okay. For example. What? There we go. Represents a property of part. Well, a list of values. How do you say this out loud? A list of values of a property of part. An array of values of a property of part. A sequence. It's like an activatable iterator. The represents the property value for each part. Each field of property chunks represents the property values for each part. No. It's the transposed property values. It's like for one field of each part. Okay, each field of property chunks represents the property values for one property of each part. E.g. C-frame. For example, part property chunk C-frame simply contains vec C-frame, which is the C-frame value for every part instance. Yeah, each property, that's a really nice explanation. Okay, each property chunk has its own implementation of the interparallel iterator trait. I can leave that out actually, which yields values of that property. For example, given the field C-frame, property chunk C-frame, part property chunks dot C-frame into parallel iterator yields C-frame. The property iterators are zipped together to yield a complete instance of that class. Instance properties. The class instances. I guess this is all one section. And then chained together into a fantastically large iterator. This is unclear wording in this section here. Iterator of complete instances. Iterators. The class instance iterators are ultimately converted into instance and then chained together. There we go. Yes, sir. Decoding complete. Do 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 do. Why don't we give an overview here? Stage 1. Stage 2. Parallel decoding is split into 2 stages per chunk, parallel, and per instance. Decoding is split into 2 stages per instance. Yeah, yeah. So that's really the key point here. The chunk layout of some property types can be known without requiring sequential decoding. Deferred to per instance parallel the chunk layout of some property types can be known without requiring sequential decoding. The property chunks which must be decoded sequentially are decoded in the per chunk parallel stage. Java Dawn, insane music. Nice. Right architecture MD. So what would this look like for the wink typed decoder? Weakly typed instead of strongly typed. Really, you could still use this half because no, right, you want right, you don't want the database to be baked into the decoder for the weakly typed one. It's supposed to be more dynamic. That's a W. Homely momely. So yeah, by like transposing the architecture here, we can have a lot more information ahead of time. Doing chunk decoding in parallel, or decompression, chunk decompression in parallel. How we looking? I'm gonna bump it. Wah, wah, wah. Linux. Where's my fork? Fork. Yeah, let's see it rendered. I guess you're gonna need to do some work here. Uh, but I'll figure it out later. Mm-hmm. Whoa, what a good idea to write this document and like I'm kind of like behaving like an AI agent. I have no memory. I must write it down. I do kind of feel like that though. Things slip my mind. Time flows quickly. Yeah, no, this is good because like you have a vec per chunk instead of an allocation per instance. The like allocation per instance is done in parallel. That's pretty cool, man. That's pretty cool. The provided binary type provided. Oops. Uh, and infers which decoder should be used. This is essentially multiplexing property chunk new with T inferred by the destination enum variant of part property chunk. Each class property chunk is inserted into class property chunks with the try push method. A massive nested structure of parallel editors is constructed using generated code and run with per instance parallelism. Each field of class property chunks has its own implementation of into parallel editor, which yields items like class. For example, given the field part property chunks, class property chunks part into parallel editor yields classes part. Each field of part property chunks represents the property values for one property of each part. For example, property chunk simply, oh, got oofed by bruh. Stupid XML. Let's try that. Jeez. Do the what? Select the branch, bro. Do it. Okay, so and the binary type provided instead of the provided binary type provided. Okay. For example, should I say the field? Yeah, okay, we made this mistake here as well. Oh, never mind. Given the field, simply well, I don't know. Is that part of that? Kinda. Let's see how it looks. Given. Why don't I take away given? I think that's stupid. Oh, you do need given right here. For you do need given. That was it is given. Given the field this, that yields part. Can you say that more clearly? Uh, yes, given. Given the field this, that yields that. Okay. Well, that is what I wanted to do. For some reason, I can't imagine how to do this with the weak types. Like, what part is different? Class property chunk is not real, basically. Like, this is baking the database. Oh, you would need like a enum. Does it necessarily reflect the reflection database structure? Reflect the reflection database? No. You just need an enum of the binary types. Kind of. La la la. Like. So it's here. So look. Binary type, canonical type. You need like a thing, an enum of this. So instead of doing this right away each time, you would like sometimes do it, and it would go into a types variant. Oh, wait a minute. I wonder if I could construct the freaking iterators, because like this this pull request oh, I didn't pull request it actually. This branch right here right, includes that change. It has this like add properties thing. And so what you could do is like you could totally just do that. Couldn't you? Like I could just smack this. Values. Yeah. Into a type variant. No, because it would be, it's a different iterator for each one. No, I don't know, for the string. No, well, no. Well, yes. Chunk. Each chunk is a different chunk. I want to try error again. Let me try that. Alright, let me try it. E. 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 Well, okay, so it actually just doesn't matter. Oh. What about E equals infallible? Oh. How do you do it then? Why? Why? Okay. Why? Defaults are being accepted in stable code but ignored. I now think I disagree with. $10 later. Whoa, 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 whoa. Yeah. Oh, basically ignored. Well, that was my idea. Can I say like result? Yeah. Uh, let's start with this. Uh, Oh. Oh, I can have little small functions actually. Yeah, I mean, undo, undo, undo. So I can go like, yeah, dude. Hey, it's E, man. Whoa, it's E. And I can go same function signature, add properties, infallible. Um, mm, uh, add properties, unwrap, and then E is infallible. There you go. And then add properties fallible. And that is always inner error. I'm going to start with that. Okay, so what can we do? Question mark. As the teeny weeny ones without bool into result variant. Right. Put it back. Are you allowed to say into here? I don't think you are. Yeah. Real. Okay, and then real. We want more. What do you want? Required by a bound. What do you want? Value is string. Yeah. And we can take away this. Oh, hell nah. Oh. Attributes, binary string. Alright, bruh. What do you want? Oh, I didn't change the function signature entirely. Okay. Y'all. Oh. VE. Shh. Okay. So I want to add this one. Okay, so read bool. What if I said like this? And then to return inner error. E. So, oh. You know, I guess I could actually. No. Okay, well, no, it'd be here. Wah, wah, wah. Wah, 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 wah. Here, yes. Fallible inner error. But no, this can be E, where E into inner error. I think that was the problem in the first place, though. Well, let's give it a go. E into inner error. E. Pain. Oh, E. Crap. E. La 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 la. Yeah, bro. So this is infallible. Real. So no into infallible. No question mark. Whoa. But I mean, it's just a more complicated version of what I already had. Float 64. No. This is fallible, but then this one is infallible because the question mark is outside of the map. Basically, anything that has infallible is chillin'. Yeah, it's literally just the same thing. Oh, we're not infallible. Unlucky. We can still remove that though. The problem is kind of that it's not the same function. Actually, is that a problem? No, right? Some iter fallible. Value question mark. Try into. Alright, dude. Color 3. This is infallible. So like the infallible ones immediately can be converted to instances start line. Yeah, it can be immediately converted into a special man. A known layout chunk. R. I like the functions being different. I think that's nice. Get or that's infallible. Question mark, that's fallible. Uh-huh. Unwrap or default? What? Gotta do something, I guess. Question mark. Wait, why is this okay? No, it's not okay. Alright, I'm kind of trolling myself here. Into rect new infallible. Fallible. Read slice into infallible. Question mark. What? Matrix 3. Read U8 question mark. Technically fallible. Probably. Should have. Should yeah. I'll figure it out later. If I ever do. Question mark from bits into infallible. Content. Pop unwrap infallible. Uh-oh. Tie. In this closure. What up? Inner error. Who's returning? Oh, there it is. Okay. Well, that's it. This is just kind of like undoing what I already did in a stupid way. I'm just like turning back the work that I did. Yeah, so from here to here, what does that look like? Oh, it's... why did I think this would help? It's just uglier. Okay. Hmm. What can I keep doing? It looked so good, but alright, let's go back down here. Yeah, deduplicate. So yeah, this one is fallible, converts to inner error. This one is infallible. The only difference is that there's no question mark right here. Or here. This is kind of dumb to name this, but iterator. Indeed, exact size iterator. Better. Blah. Blah, blah, blah. What about the merge? Use it. It's here. No? Oh. It sucks. Infallible. There's a lot of infallible. How many is there? 18 and fallible 23. Wow, that's more or less 1-to-1 with whether or not the chunk layout can be known ahead of time. I didn't know it was that nice. I think this one looks nicer in the code. Like, so nice. I don't need map okay. But then if you look at the definition, it's like it farts twice. It's the same function twice. Like, the only way is to macro it. But that's dumb as well. I would love to add rayon to this library. Rayon feature. Why is this? I don't know. I don't know how to make it not suck. I tried several different ways. How do you deduplicate this code without it sucking? I can't really imagine that adding multi-threading would make it like 10 times faster. I mean, there is like 60 properties on the parts, so like okay, so what we saw is that half of them, 23, are fallible, so cannot be decoded in parallel, and 18 are infallible, so can be decoded in parallel. So okay, but the other maintainer said that the majority of the time is spent in unification, meaning putting it all into one hash map of instances. These are the instances in the file, and not on decoding. So then that, let's say that's like 30% of the time decoding, 70% of the time on unification. We still can parallelize the unification by making this architecture change. So if it can use 32 threads, then that's like attacking the big 70%, and it can still use like 60 threads on the littler 30%, or 32 threads, like 60,000. So the parallelism limit of like when the number of cores stops. Is that a Boyd? Is that a bird? Gotta be a bird. It's a weird shape. Bird. Parallelism. Just like slightly above my monitor. Usually I have the window closed. No distractions. Or like the shade is drawn just enough so that I don't have anything to see out the window. Know yourself. I think it would be a good idea to try this because I can see it in full, and like it was too hard to do it, or it is too hard to do it all at once with also writing a strong typed decoder. Um, but the architecture is good for parallel decoding. I think I've cooked. I just have no idea whether it can actually make a difference, or if it'll be like, oh yeah, it's 10% slower, you goobert, because it doesn't actually. It's not actually parallelism. It's false sharing. But the false sharing is not really a problem because all of the shared strings are created ahead of time. Yeah, no, this would kind of be a type state refactor as well. Multiple refactors at once. Hum. Reimagined. The deserializer reimagined. Why? Why so referencing? Can you just like move it in? Double indirection. I wonder if that has a performance cost. Database lookup. Double indirection. Follow two pointers. I'm so interested in making this library faster. So interested. Why don't I write... I'll take my architecture here and write a new one. Oh my goodness. Do I have a branch called parallel already? Rayon. Haha. XDDD. Right. So what was this? This is on top of another branch. Categorize chunks. Right. So this is chunk parallel. But to really make a difference, it needs to be more. Sure, we'll call it Rayon 2. Alright, grab this. Uh-oh. Delete. Okay, so now I need to remove any mention of this thing is basically type infos, isn't it? Because you're just collecting the property, the properties, chunks. You cannot chain. Interesting. Well, no, you don't need to chain. How do you have a hash map of parallel iterators and then dynamically construct another one? You have the parallelizable property chunk data. Yeah, yeah, this is hard. No wonder I was struggling to do this and strong types at the same time. Go away, bot. Ugh. So I need these are strongly typed, but I would need to not be. It would need to have a hash map. Once again, I wonder if it would be faster to do it like this without parallelism as well. You never know. You don't know until you try. Oh. Aha. I could use struct. I could use um I could construct the iterators very specifically and then add parallel versions of those iterators. I think that would be one way to do it. Probably would have a lot of code. Mm. Mm. Oh my god, it's hard because the code is already written. I wonder if there would be any like parallelism bugs. Surely not, because it's eventually consistent. Oh, it's possible. Yeah, because the it knows the order. It maintains the order, the final order. It's like it sets up the source and sink, and then just does all of them in parallel, but into the same slots, into the same order. So what is an equivalent? Yeah, true, true. How? Wait, into parallel iterator? Uh, no, it can't. Because it needs to like zip next. You just can't, right? Next, you can't next. Okay, so that's okay. So the root problem is that if I have a hash map of property chunks, I'm building a part. Here's the names of all the parts. Here's the size of all the parts. Here's the C frame of all the parts. It's a hash map. What is the size chunk values? It's this. What is the this values? It's that. So it's a hash map of all the values, and then you need to turn that, basically transpose it into each into like what each instance has a name, size, C frame, but it has to be parallelizable. How do you do that with a variable number of properties? Hello 0 1 VT. I wrote a plan for how to make a parallel decoder for Roblox files for strong types, but I think I should try to use the same architecture for weak types. The weak type decoder for the binary files already exists, but it's slow and I don't like it being slow. So I keep trying to think of ways to make it faster. And now I'm trying to do multi-threading. And I have this idea where you have two stages. You have per chunk parallelism, because the file is organized into chunks. And that's one opportunity for parallel decoding. But then you also have per instance parallelism, which is a much stronger parallelism, because these files have like, let's say 60,000 of one type of class, one class. So like parts, Roblox parts are the most common. You're gonna have like 60,000 parts, and then like 3,000 of the next most common thing. So it's very top heavy. So parallelizing per chunk, you're still waiting on 60,000 parts in serial unless you parallelize per instance. So I need to prepare, if I want to have per instance parallelism, I need to prepare the non-parallelizable data ahead of time, and taking advantage of per chunk parallelism to do that seems smart. So about 50% of the properties, you can know the layout of the chunk ahead of time, and then the other 50%, you have to decode it in sequence. So the ones that you have to decode in sequence, we can do that with per chunk parallelism. And then now we have parallelizable data prepared, and then the data that was already parallelizable. And we do per instance parallel. But how do you transpose a hash map of a struct of arrays into an array of structs in parallel when you have a variable number of iterators? It's not necessarily an iterator yet. It's something that can be turned into an iterator. Oh man, back to the struct of arrays transposition problem. I was trying to figure this out for the strongly typed decoder as well, and I think I did. This is the plan, but it's very strongly typed. and it's using generated code to tackle the transposition problem. Structive arrays to array of structs. It's like it just like is actually just generating the code, or the plan is to generate the code that does that transposition. So because you know how many properties there is for a part, there's like 60 properties, 63 or something. So it would have like 63 lines of code that are like zipping together the iterators to produce a new iterator. But you can't do that. I guess you could just... Yeah, I'm trying to avoid bounds checking as well. Iterators are great for that. But I don't necessarily have to use iterators per property chunk. I could transform the hash map of property chunks directly into a parallel iterator. But then how do I make the bounds checks? I guess you have a lot of threads on it. I don't know. It's just nice. Wait a second. Don't you have bounds checks anyways? I should probably stop thinking about omitting bounds checks. It's just an extra thing on the pile of things I need to keep in my head. It's like a very small performance factor, and I can just optimize it away later. Figure that out. This is what was in my head, and I wrote it out. Oh. Wait a minute. It doesn't have to be a hash map. Their instance builder uses a vec instead of a hash map, which I find wild. Absolutely wild that it's faster to do that. But you... multi-zip. It's a dynamic multi-zip. Wow. I mean, the multi-zip isn't even that efficient anyways. Rayon multi-zip. Okay, where is the code? Rayon interior designers. Okay, take me to the source code. There is nothing. Servo. What? Rust Max. What? What? Like what? Huh? Rust maxing, exactly. Alright, freaking Rayon source code. Jeez. Alright, multi-zip. That's the one. Yeah. So the deal is that it's a tuple, and you know how many zippers you're zipping at compile time. She? Because it's a macro. But it's not that good. Par. Into par. Yeah, it literally when you call the length function, it just calls all the length functions and then min. Wait, reduce. Crazy. Whoa. Wait, what? Wait, what? Oh my god. A B C D. This is going. What? Really? Greedily consumed 4 or 2 items. Log 2 nesting depth. What? I didn't know it was implemented like that. That's nutty. I could just steal this macro instead of using multizip. I could steal the source code and like have it just write it for the. What is? Because 60, you have 60 properties. Why didn't I think of that? Like, look at this. It only goes up to 12. Why is it? Why is it named? What the hell? Multizip impulse. My man. Tuple ident. Why? Uh, why is that capital letter as well? Wait, what? Wait, what? Wait, what? What? One of one match. Why does it show up there and there? Oh, it's this stupid thing. Okay, I see. Okay, so it's irrelevant. Why? Why bother? Like what? Just put a freaking tuple. Okay, whatever. Maybe I don't know. Macro. It doesn't. It doesn't matter. It doesn't matter. Um, if I could steal this macro, that would be nice. But freaking wacky. 12, 4, 8. Real. Hmm. Well, that solves another problem. Because then you can macro on the macro. Macro it up. I wonder if this is all available. It should be, right? Because so literally just copy this file and define the ones. Well, no, you don't even need to define the ones you need with tuple. You can just make a dedicated one for each. How do you? Oh, I guess you don't need to actually. You don't need to flatten the properties. They're the same property names. They just exist in both. So you'd have a list of all properties and a list of per superclass properties. But I'm not writing this code right now. Okay, but it's still cool. Okay, this doesn't work for dynamic runtime into iterator. Hash map. When you have a hash map of the property chunks, or a vec, might also. So if there's 60 property chunks, because you have part properties like this. That's like these are C frames, these are sizes, these are names, part.name, and then you take one C frame, one size, and one name, and that's a part. Don't, that's a part. Don't, that's a part. I need to like do that somehow if I want parallel decoding. Gosh. I've already looked at the source code. Where's the dunk definitions? Par. Par. Eh. What? What's that? From par iters. Iters? Oh, it's just poorly named. Okay. Unlucky. That's what I need is from parallel iterators. Parallel iterator from parallel iterators. What the hell? Tuple. What? Goop. Goop. Nope. Nope. Damn. Why? Literal. Desk. Okay. Okay, I want the definition from mod. Okay, geez, it's in mod. Okay, what do we got? A lot. We got a lot. Many thousand lines of code. Just straight into mod. Into parallel iterator. I've read this before. Oh. Oh. Oh, cool. So this one, parallel version of the standard iterator trait. But then there's a better one, indexed parallel iterator, which is implemented for like VEC and stuff, because you can just index it directly. Oh. Go next. There it is. Indexed parallel iterator, with parallel iterator as a super trait. Iterator that supports random access. You can split at arbitrary indices and draw data from those points. That's like the real magic. Oh. Always cleared. It's a blender. Why is there... I don't know. I probably just would have to think about it for a second. Why is it in this indexed parallel iterator and not in the parallel iterator? But it probably makes sense. I'm just not thinking about it. What am I looking at? Right, I wanted to see the definitions again. Right. Okay, but then you would do hash map iter, right? Direct collect into a new hash map. Yeah, transposing a hash map, that's hard. What if I convert it into a parallel iterator and each property chunk is a parallel iterator, and I just like multiplex the calls, like split at. Oh yeah, just split at, split at, split at, split at, split at, split at. Well, I guess I've been doing it this way. And then you just make a new hash map. Just like iter mut split at collect. To a new hash map. It shouldn't be that bad, because that's how it works. That's how Rayon works. Is it's like using heap allocations. It's paying the heap allocation cost to leverage multi-threaded goodness. So you have like collections of length number of threads. And like it would definitely not be faster if it was just one thread, because you're like allocating and then doing the thing instead of just normal iterating. Hash map. Alright, split at split Split. Split. Is it? Did we not see it yet? Oh, hey, what's up? Splits. 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 Splits, splits, splits. What? Pool. What? The elements of the what? Self.comp. It returns. What? I into parallel iterator. I other. Is that? Oh. Oh, it is doing it. Okay. Zip. Yeah. No. Okay. 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 All. Okay. It's all. It's. That's. That's freaky. We like weird. Why? So you have to be indexed to have enumerate? Where's the damn split at? Take me to it. It's not real? One of one match. Lies? Lying? What? Alright, I'm confused. I'm officially confused. And that's the end of the trait. I've been eating salmon to get that omega-3 fish oil fatty acid so I can super brain think really hard. It's not working. Why do I care so much about this library? It irks me that decoding a file takes 300 milliseconds. It should be 2 milliseconds. That's... I'm irked. Where's my something? Right. It doesn't just need to index it. It has to move the values out, take ownership for the struct of arrays to array of structs transposition. It's tricky, because you have ownership. You have a single contiguous heap allocation that has to only be dropped. How did this damn library work? Vec. Into iter. That is the thing. I've read this code before. There's so many layers. parallel drain. How does it split? Oh, it's with references. Split. Where's the split? Yeah. Split at. Now we're talking. Drain producer new. How would you compare Rust with other languages for game development? Well, I wrote a game engine in Rust. Is it already built? It's already built. Is that gonna work? It is gonna work. But unfortunately, the only other language I have experience with. Wait, can I full screen now? Is it gonna lag the stream? It used to lag. The NVIDIA driver was bad, but it got better. Yeah, this is 3 years of effort. I need to get back to working on this. How would I compare? So Lua was the language that I used before, and I was making games in Roblox. What I appreciate about Rust is the ability to prevent my future self from making mistakes. So if I make some sort of type that has a very strict interface, so like, for example, the string type in the Rust standard library is guaranteed to be a valid UTF-8 string, because the only way to create a string is by calling string new, and string new checks to see if it's a valid UTF-8 string. So if you receive a string type into one of your functions, you know for a fact it's valid UTF-8. It's just a sequence of bytes, but because it's a string type, it's checked, it's verified, and it's impossible to misuse it in safe Rust. Of course, you can like open the escape hatch and throw all of your guarantees away and like write the most performant code in the world, but generally it's easier to stick to safe Rust because you get so many guarantees. But you can do this for yourself. You can teach the compiler how to maintain the invariants that you want, such as I want strings to always be valid UTF-8. What would I want in my game engine? It's been a while since I worked on it. Right. So I made a math library for this. That's kind of just strong types, but it's just extra powerful with Rust. Because like the Rust language is all about guarantees. It's like a central principle, and like the entire Rust ecosystem is focused on correctness. String is just a really good example, and I'm blanking on what I actually did that's like that in the. So like, if you're trying to make a game, probably, and make money right now, probably you should just pick a game engine and go make it. It'll be way faster. What I wanted was sort of a programming garden where I can go here and do some gardening every day and at the end of it, I'll have a cool game. It's kind of like the programming is the goal. The goal was to do programming, and that's quite different. Um, Mature game engine development libraries are much more C++ oriented. Yeah, making a game engine in C++, there's it's been around for much longer, and most game engines are written in C++. But my bias is towards Rust because I like guarantees. I like to guarantee, so I can think once, figure things out once, and then it's correct forever because I have this safe interface. I never talked about the math library I made. So I made a math library that is somewhat unique. It has a new idea. And the idea is that when you multiply two vectors together, vector 3, so like x, y, z, instead of using floating point numbers, I'm using fixed point integers. But now I have the problem of, oh no, they're going to overflow, right? Because like if you multiply a 32-bit number by a 32-bit number, the result will be up to 64 bits. So my unique idea was, what if you widen the result? So when you multiply two numbers, the return type is different than the input types. So like if you have 64 bits on the left hand side and 128 bits on the right hand side, when you add them together, or when you multiply them together, the result type will be 192 bits wide. So the result will always fit. But of course now you're multiplying 192-bit numbers, so you get perfect precision during your mathematical procedure, but the longer you go without checking the number and like verifying, I just clipped through a wall. The longer you go without checking, the slower it'll get because it has to do wider multiplication. But that was fun to come up with and think, and like, because I don't like floating point numbers. That's the whole deal. I did a small game dev project with C# before. Oh yeah, like Unity is C#. Microsoft flavored Java, right? No problems with it, but I got roasted by a few people, so I'm trying to prove them wrong using Rust. That's a great reason to use Rust. That's basically the reason to use Rust is that you want to learn Rust. It's there's just so many valid choices you can make. Like using C++ is valid. Using C# is valid. When you're making such a big project such as a game, the best way to do it is to use what you know, because like all of them are Turing complete languages. They can all achieve things. So by using what you know, you can accomplish it the fastest. But now if your goal is different, I want to use Rust to prove them wrong. Now you have a reason to use Rust. Yeah, it's something different. Using Rust is like unfamiliar in terms of the concepts in different languages. Like, have you explored ownership and borrowing, the core tenet of Rust principles? It's unfamiliar. No other programming language has this concept. And it's like it's this same idea of like restricting yourself to gain guarantees about what you can prove that your code does. So like with the strings, you're restricting yourself to not be able to use the underlying bytes willy-nilly, so that you guarantee it's always valid UTF-8. And then with ownership and borrowing, you restrict yourself to not be able to have mutable access and immutable access at the same time, so that you can prove that your program is memory safe and has no race conditions and has no all sorts of guarantees. Don't like floating points too. We get F32. Other languages, it's only F64. Oh, that's true. Lua, number. Does JavaScript have a float 32, a way to access that? I imagine it does, because of how much stuff is added to it. It's like the C++ of weakly typed languages. Weak. Ugh, damn. Oh. 3 at a time, 3 at a time, 3 at a time, 3 at a time, 3 at a time. Yeah. And then bug. Unlucky. That's the end of the map. Cool. Well, it looks like the NVIDIA driver is no longer displeased with full screen applications to some extent. The performance is better. What's my time? 10 minutes, 31 seconds, 870 milliseconds, 673 microseconds, and 754 nanoseconds. I like the overall idea of restrictions. Stressed about implementing one simple thing. There's so many ways to do it. That's kind of a different restriction. Like in Rust, there's Rust string types mean. Yeah. So before using Rust, string. After using Rust, Rust has a lot of standard library ways to represent a string of characters. But it's all about these restrictions where each one serves a very particular purpose, such as pathBuf is a string that you send to the operating system, and it works on Windows, Mac, and Linux. Yeah. So like having restrictions doesn't mean that there's not more than one way to do it. It more means that you can make certain guarantees about how about using it correctly in the future. You have to think about it once, and then it's perfect forever. I can explain each one of these. This is a string slice, so it's a reference to a string. So it's a reference. It knows how long. It can be in anywhere in like a contiguous sequence of memory that's guaranteed to be valid UTF-8, and the slice is guaranteed to be valid UTF-8 as well. People use byte slice. That's a byte slice. Yeah, so like if you have a string that's not UTF-8, you probably want to use like UTF-16 or something. Ah, what's this? Huh? What? What was that about? Not UTF. Wow. Wait. Is it like this? Huh? I thought there was a huge one. Whatever. Okay. Uh, yeah, that's a byte slice. So that's like if you're just dealing with binary data. There should be something in here. Types. Source. Binary string. So yeah, binary string is just a list of bytes. This is a variable size array. And then you can just, yeah, I don't know. Do people use? People use all of them. All of them are useful for particular use cases. This is just a reference to a byte, which is it's a bit weird. I don't think I've seen that. This is a reference to a fixed size array. This is a substring of an OS string. This is a sub path of a path buff. So this is owned, the ownership. It owns its own allocation, whereas this is just referring to it somewhere else. And that's the same with this one, where like this one is referring to it somewhere else, and this one is owned. And then this is compile time, or well, not necessarily compile time. It's a static lifetime, meaning the reference is valid until the end of the program. Oh yeah, lifetimes. Lifetimes are something that exists in every programming language, but never gets a name. Only Rust and some other esoteric languages have a concept of lifetimes, where like you create the data, the lifetime begins, and then you delete the data, the lifetime ends. And it explicitly expresses the lifetime of the data within the code so that the compiler can prove that your lifetimes are always valid using ownership and borrowing. So like when you refer to data, it shouldn't get deleted while you're referring to it, the reference. And the ownership and borrowing exhaustively proves that all of your lifetimes are valid everywhere, in all instances. Guarantees. It's about the guarantees. It's guaranteed to be valid. God damn. The goop is just shooting off of my eyes onto the inside of my glasses. In C, you would see a pointer 8 bytes? What, like pointer sized, like 64-bit architecture? Made use of pointers in Rust. Makes me confused about Rust. Yeah, so Rust abstracts raw pointers. So in C, you're always using raw pointers because that's how it is. In Rust, you're using references. And the references have these guarantees where, so like in C, you have a null pointer, right? And so you always have to check, is this pointer valid? The data can stop existing, like the allocation was deallocated and it's pointing into a invalid memory location. Doesn't happen in Rust. Rust uses references, and these references are checked at compile time by the compiler to make sure the lifetimes all work out in every code path. All of your code. It checks all of your code to make sure that when you make a reference, the data that it's referring to exists while the reference exists. So you create the data, you create the reference, you delete the reference, you delete the data. You can have raw pointers in Rust, but you have to like open the escape hatch and use the unsafe keyword, and you're basically telling the compiler, I know what I'm doing. I promise that I will write memory safe code, and the compiler will allow you to like dereference a raw pointer, even though it might point to an allocation that no longer exists because it doesn't have the guarantees of a Rust reference. So you could still use raw pointers, but you don't get guarantees. You've opened the escape hatch. You have to promise that you uphold all of the things, and then the compiler assumes that you wrote correct code instead of proving it itself. I promise my code is safe and correct. Let's see, how many instances of unsafe? Oh, hey, it's the game engine. Do I have in my game engine? Unsafe. 336. Oh, this is in like Golang and Lua as well. Okay, how about we filter by .rs. 14. All right, let's see it. All right, that's a comment. That's a comment. All right, here. This is in my math library. I'm transmuting an array of two values into a single value because the memory layout is the same, and there was no safe interface to do that. And this is also my math library. This pointer is non-null because it comes from a reference. I believe this is named field access for a array. So like when you have a vector, yeah, named fields. When you have like a vector in my library, it's a fixed size array, but I added this dereferencing tool so I can do vector.x when it's a vector 3. So I can have vector 4, vector 5, but if it is specifically vector 3, macros, then I can say .x, named fields, game. Where is this? Oh, is it mod? Yeah, right? No. Huh? Vector. Oh, there you go. Named fields, vector 3. Jesus. What? Did I do it wrong? Where's this guy? Huh? Huh? Okay, this is just cross product. Okay, where is this? Okay, I got distracted. Okay, it's named fields because it's transmuting one thing or another. Maybe I should use transmute. Oh no, I think I replaced transmute. Trying to stay away from doing unsafe. That's a good idea for learning. Oh, this I just couldn't figure out how to do this. I wonder if I can figure this out now. Ain't no way. Definitely unsound. Let's see. So it's closure because it's referencing this in both closures mutably, but they're chained together, so they'll never access the same value at the same time. But this is like instant UB. I think this is unsound. Unsafe, unsound. Good job, past me. I was just done with it. All right, what about the other ones? Extend lifetime. Yeah, that's unsafe. So I turn it into a static reference. I turn any reference, I extend the lifetime to infinity. I'm like, this value is going to live forever. Trust me, Rust compiler. But it's because this thing requires it to live forever. And I have tricks that I'm doing. Ugh. So yeah, how big is this code base? Uh, 25,000 lines of code and 14 unsafe. Well, 12? Oh. 11? I mean, these are all one. I guess that's coping. So yeah, you can... I could probably not do this, but I just really like fast stuff. So... Can I do cast? That's what this is, right? T size self dot array. What if I it's inside a macro. Yeah. If you still want to learn Rust, I recommend the rustlings exercises. That's what worked for me. It got me reading and writing Rust instead of just going like, man, I wish I could read and write Rust. Basically, it's a bunch of programs that do not compile, and your job is to fix the compile error. That's returning a vector pointer so you can use it almost anywhere. No, it's reinterpreting a array as a struct. So it's an array of 3 numbers. Imagine it like a vector 3. So there's like float 32, float 32, float 32. And this code is the type is an array of length 3 of vector 32, or of float 32, F32. But then when I dereference the type, which is a Rust operation, dot, when I type dot, I can say dot x, and it dereferences it as a struct with named fields. Where's the 3? Help. Named fields. Why? It's here, right? Named fields. Oh my god, bro. Where's the named fields? Named. There we go. Wait. Where is it, dude? There it is. Jesus. Repr C. Really? I mean, I guess that's okay. Impl vector named fields. Yeah, so it's just 3 of the same value, right? So that's the memory layout is equivalent to an array of 3 values. So then if I dereference it into this type, now it thinks it's this type instead of an array. I'm going to do .x, and that has a specific offset, right? So this is offset 0, offset 1, I guess, offset 2. And it's just convenient to write vector 3 stuff with field names. But it requires unsafe because you're reinterpreting one type as a different type. There's no way to do that without unsafe code. Well, no, I could do it without unsafe code, but it would involve moving. So deref, I have a reference to the array, and I'm trying to not copy it, right? I just want to like make the compiler think of it differently so that I can access the field by name. What I could, well, no, actually I can't I can't copy it because this returns a reference. Yeah, there's all sorts of invariants I have to uphold. Forced to do it in a specific way, the right way. Very interesting. Draco. Oh, Draco. What was I up to? Right, I was thinking about architecture and I was failing. Right. Transposing struct of arrays to array of structs. I'm going to put my coffee away. I'll be right back. Yeah. Well, there's your in-depth overview of Rust. So it's very like conceptually exciting, but it's definitely not as mature of an ecosystem for game development as C++ is. So like if you just like want to use ready to go components like the physics engine and rendering and the sound and stuff, those do exist in Rust. Like there's the Rapier library, the sword Rapier for physics. There is the CPAL cross-platform audio library for sound. There's what about for rendering? WGPU for rendering. I'm using that in this project. So like it's there, but they were made yesterday compared to the C++ libraries. Immature. Whereas C++, you have Jolt physics engine, the best physics engine ever. Which I believe there's also Rust bindings for Jolt physics engine. No way. I really want to write. I mean, I guess this is sufficient, really. Gosh, I don't know how to do the transposition. Struct of arrays to array of structs, but the struct is actually a hash map. The number of fields is variable. New problem. I mean, I should be able to just implement the trait and just allocate a new one every time it wants to split it. Yeah, in fact. Ah. Ah. Indexed, surely. Gugh. No. Okay. Wah. Awa. It's, what is it? What is it? How do you do the chunks? So the problem is the type needs to be known and the same in the hash map. Whereas if you have a struct with fields, each field can be a different type. Do you recommend using a string reference instead of string instructs? Whenever I want to apply modifications, converting it back. In terms of performance. So unfortunately, the answer is it depends. There's like rules of thumb you can follow. Like when you're accepting arguments to a function, generally you use a reference so that the caller can decide whether or not to do allocation and stuff. But like it's less Rust is so fast that it's less important when your project is small and you're first starting to learn. I recommend clone everything. Just like if you run into a borrow checker issue, clone it. Just allocate a new string. It's slower technically, but you're probably not going to notice until you do eventually. Your project gets complicated enough and you have enough like nested hot code that you actually do see the slowness and you need to actually figure out what's going on. But at that point, you'll probably know Rust better and you'll have your own opinions of how it should be done. Just clone everything. It's not optimal, but it'll solve your problems and you can actually focus on what you want to do instead of fighting the borrow checker. That's very common when you're learning Rust. Is like you're fighting the language instead of just implementing what you want to do. What I found happens, I started learning Rust in 2022. What I found is that eventually I could predict what the borrow checker was going to say. I would go, oh no, that's not going to work because that has a mutable reference and an immutable reference at the same time, and that's not allowed. Well, I should do it this way instead. And I would just already know to do it right in the first place. And so I wasn't fighting the borrow checker anymore. But it's definitely a point of friction when you're learning Rust. It's like, oh, why doesn't it just work? Because you're so used to having this like interior mutability thing where you just reach into the object and just... But it's not like that in Rust. You can't just mess with stuff. You have to very carefully have these ownership and borrowing rules. And it kind of forces you to write the program in a very performant way if you do follow the borrow checker rules. String is also cloning. Yeah. Yeah, so like it's same as it ever was. when you do clone, but then once you do figure it out, oh, now you got the speed. But it doesn't really matter unless you're in the really hot code. The hottest loops. The loop. Just random anecdote. It's really interesting. I chose Rust because of memory safety. I have tried to like make the like Vulkan triangle many times in C++. I just didn't get it enough, and I've written some C++ code before for some project with another friend, and he said that I wrote like almost every line of code I wrote had memory leaks and stuff. I just was like, I suck at this. I don't want to deal with memory leaks. So that's why I picked Rust. The funny thing is that memory leaks are actually memory safe. So Rust technically does not guarantee that there's no memory leaks. But in practice, there is no memory leaks. It only happens if you have like a self-referencing data structure where like node 1 refers to node 2 and node 2 refers to node 1. And then you drop all references to both nodes and they're like reference counted. So once the reference count reaches 0, they're dropped, but they're both holding on to each other. And so they're just kind of somewhere in memory that's inaccessible. There's no references from anywhere else to there. And that's totally memory safe. But it's a memory leak. But it's memory safe. It's memory safe. I don't use reference counted values in my game engine. In Rust, it's called ARC, Atomic Reference Counter, or RC. ARC. Help. Inside strafe project. Nah. Let's do all one word. Yeah. So there's one thing, and this is actually dead code that's never used. What about RC? I think I have one, and it's in like a Roblox compatibility thing, and I was like, man, this thing is bad design. The only way to do this is with reference counting. Reference counting is essentially manual garbage collection. So this is the only place in my code where this exists, and I don't use it either. Everything is like very carefully scoped, and I have like mutable references to this and then immutable references to this, and it's only, and they're never at the same time, and it's carefully organized. This is ownership over here, and then we reference into this. Carefully crafted to have all of the ownership and borrowing proved at compile time, and no garbage collection and stuff. And because I've done that, I never have to think about memory for the most part. Other than like the memory layout, like, oh, what's the best way to pack these values so that it's the smallest? But like remembering to free memory, nope, don't need to do that. Vec, it owns its backing allocation, and so when this value is dropped, when it goes out of scope, it also drops the memory automatically. It's resource acquisition is initialization, RAII, which C++ does have that as well. Oh, modern C++ doesn't have those problems. We only have 37 guns pointed at your feet, not 250. Oh, you must not have used modern C++. Sorry. What is that? That looks. Oh no, that's the RC. I see. Yeah. Okay, it's doing the goober. So the reference counted ref cell thing, it punts the borrow checking to runtime. So this is borrowing mutably, and you better hope that you're not borrowing immutability at the same time. So if it borrows mutably and then tries to borrow immutably at the same time, it'll just crash your program, which is safe. That's memory safe. Rust promises memory safety and not your program won't crash. But in practice, it doesn't crash either because of more Rust concepts like these result types where errors are values. So this function returns a result, which means there can be an error. And I don't know where the call site for this is, but in the call site, I need to do stuff like this. So this can have an error. It's a result. Question mark is checking, was it an error? Oh, well, then we're going to propagate the error up. And this function will also return an error instead of success. So when there's an error, you must handle it in some way. Either you say, oh, just crash the program if there's an error, but that's written explicitly, or propagate it up the call stack. Or actually, for this error, we don't really care, just like log something, or like it's expected to error. Oh my God, it's great. Love, what is it called? Algebraic types, where you can have an enum of structs and a struct of enums. The depth of the type can be arbitrarily large. That did not exist in Lua. Brand new concept to me. No, C# doesn't have algebraic types either. It's such a impressive breakdown of programming concepts where the entire Rust language is also written in Rust using these like primitive abstractions of structs and enums. Everything is a struct or an enum. Well, I mean, you have like arrays, but array is essentially a fancy struct. You have sum types and product types. That's the algebraic type system. Yeah, traits, whole can of worms. And like everything like fits together so excellently with like traits, lifetimes, structs and enums, and it all works together. It's a beautiful symphony. And you get memory safety, zero data races. As long as your program compiles, it has these guarantees. All right, it's really hard to stop glazing Rust. There's so many amazing things. Not too familiar with this stuff. Yeah. The rustlings, the exercises, it takes you through everything, like lifetimes, traits, and everything. You'll be reading and writing Rust in like a week or two. I think I completed it in a week. It was just night and day before and after. Like Rust is really hard to read when you don't know Rust. With all the, like this is called a turbofish. Yeah. Colon, greater than, or less than symbol. Colon. Why is colon written everywhere? Oh yeah, closures. Just the most insane syntax. This is like open parentheses, close parentheses. This is like a list of function arguments inside of these bars. Closure syntax. So this is an anonymous function right here. Wild stuff. Oh yeah, there's another one. Anonymous function. It all compiles away. Zero cost abstractions. Zero cost abstractions. Rust is all about zero cost abstractions. All of the cost is at compile time, and then it's, what is it called? Blazing fast at runtime. Still glazing Rust. It's so hard to stop glazing. There's always more to talk about. Oh yeah, there's this amazing feature. Oh yeah, have you heard of this amazing feature? Ah. Oh, how's this doing? Not merged yet. What was my card game? I wrote a card game in Rust. And like maximizing. Okay, here's a nice mantra. It's make invalid states unrepresentable. Using the Rust algebraic type system, you can make invalid states unrepresentable. Where, okay, for example, here. Why don't I go here? Card game. This is the library. Klondike. All right, let's play the game so we can see what it looks like. Get card game, CLI, cargo, run. All right, so this is the card game. It's just command line. It's all like implemented logically. So what I can open up. I mean, yeah, it's Klondike. Solitaire. So we can move Tableau 1 onto Foundation 1. Tableau 1 onto Foundation 1. And so it's taken that card and moved it to here. Tableau 2 onto Tableau 4. Tableau 2 onto Foundation 2. And I also have autoplay. It can like auto move. Okay. Cool. Ah, it got stuck. Why is it special? So it's special because I have made as many invalid moves unrepresentable as possible. So this is a Klondike instruction. So you're moving a card from somewhere to somewhere else. So what can you do? This is an enum. So either you're moving something into the foundations, or the destination is Tableau, or you're just rotating the stock. And these are mutually exclusive. So it can't be both of these. It's not like a struct. So when you have a Klondike instruction, it's either DST foundation, or it's DST Tableau, or it's rotate stock. That's an enum. It's a sum type. So what is this? DST foundation. Well, that's a struct. So this is describing the card source, and this is describing the card destination. It's a foundation. You're moving it into a foundation. So there's something different about moving into a foundation than there is about moving into a Tableau. Why don't we get like a picture? Klondike. Oh. Wait. Oh. Wait. Oh, never mind. Dang. Okay. Klondike. Images. Yeah. Oh my god. You can do that? You can just make more? I mean, I guess that's obvious. Actually, I wonder if I can run. Yeah, I don't know. I'll just keep this picture up. Okay. So the thing is, so like look at this. Oh. Okay, so when I move T1 to T6, I'm moving the entire stack. T1, T6. That's moving multiple cards. But you can also move less, right? So So moving from here, 8, 7, 6, 5, 4, onto T5, to move T6 onto T5, it only moves 4 cards. That wasn't the whole stack. So that's the difference. The difference between moving onto a foundation and moving onto a tableau is moving a stack of cards versus not moving a stack of cards. So moving into a foundation, you're always moving exactly 1 card. So that's why this is an enum, because the way it works is represented differently depending on the destination. So I have the structure changes depending on the destination, and so like if I had just what's the source, what's the destination, you could represent more invalid moves because you're like, oh, I want to move this whole stack into the foundations. Differentiating it using an enum, yeah, it's carefully laying out your types in terms of structs of enums and enums of structs until you've reduced as many invalid states as possible. So there is still invalid states here, or invalid moves representable, such as like I could represent the move move 13 cards from here onto here, and like, well, that's an invalid move because you need to move it onto a queen, and oh, there's not enough cards. There's not 13 cards there. Right? So there's still invalid states, but you can't really take those away without it getting insanely complicated. So like the board representation, it just has cards in each spot. But what you could do is like list permutations like of possibilities and say, oh, this is possibility. This is possible board number 6,754,000,000,000. And then you could have like a graph of possible moves between all possible boards. Okay. Too much. You're going to have to spend significant compute to unravel the like permutations and stuff. And it just doesn't really make sense, but it's still interesting to think about. I highly recommend making a card game as a recreational activity. If you like programming, probably it'd be fun to write in C# if you know C#. But yeah, so destination tableau, destination pile stack. So this is moving a stack of cards. What is a Klondike pile stack? So it's the source card where you're moving from. It's moving into the tableau. So you can move from the foundation into the tableau. You can move from the stock into the tableau. And you can move from one tableau to another tableau. Okay, so the source, the card source, where you're moving from, it's from a tableau. Yes, you're moving a stack. From the stock, there's only one stock. From a foundation, well, which foundation? And you're only moving one card from the foundation. You're not moving a stack from the foundation. So very carefully enumerating possible moves. Tableau, stack. Which tableau and how many cards do you skip and take all the rest? Yeah, it was, I made a mistake when I first implemented this where you could only move one card at a time. I forgot you could move stacks of cards. How embarrassing. Where's the freaking state? Klondike state. So I even went super hard on this. So look at this. The entire game state is 232 bytes. So all of the card locations and like how many cards you have in each foundation and all the stock cards and everything, 232 bytes. And each tableau is a different size. So I don't actually represent whether the card is is face up or not, the location of the card represents that. So the foundations are always face up. The stock has a pile, and the pile has face up and face down cards. And the stock contains 24 cards maximum. So I'm using fixed size arrays. This is stack ArrayVec. So the maximum capacity of each pile is known at compile time. You know Tableau 1 will always have 0 face down cards because that's over here. It always has 0 face down cards. So I've represented that at compile time. And then it has up to 13 cards because you can go king, queen, jack, all the way down to ace, maximum per face up. Really went hard trying to like optimize. Yeah. And then here's this is the core logic right here. It's really, really interesting. So this is the function that checks if your move is valid. So you have this Klondike instruction. I want to move these cards to here. And this returns a Boolean value, true or false, whether or not it's a valid move. So can you rotate the stock? Well, if it's not empty, you sure can. Are you moving into a foundation? Okay, well, there's special rules for that. We're checking the top card at the source, which pile you're trying to move it from. Okay, that's the source card. If there exists a source card, because maybe the source you're trying to move it from is empty. If there's no source card, you're not allowed to do that. You can't move a card from an empty thing. But if there is a source card, well, now we're inside this if statement. And then checking which destination we're moving it onto. Okay. So this is grabbing the topmost card on the destination. So in this picture, there's nothing. In this picture, there's, let's say, ace of diamonds is our destination card. So if the destination card exists, then does the suit match, and is the card rank increased by 1? So if it's an ace here, this rank is ace 2, 3, 4. You can add 1, so ace plus 1 is 2. So is the source card rank equal to the destination card rank plus 1? Right? Makes sense. If the destination card does not exist, if it's a none value, then we're moving into a blank foundation, and only an ace card is allowed to move into a blank foundation. It's all extremely strict and typed. You're using this rank enum. You can only compare with another rank enum. Strictly typed. Strongly typed. Same for Tableau. It's all very strict types. I love this. Love it, love it. So the redness has to be opposite to move Tableau to Tableau. Oh, it's so rusty. And then, of course, there is the actual move logic as well. So this receives an instruction of what to do, which is a Klondike instruction. And then it actually does the move. So rotating the stock, flip it and reverse it if it's empty, or flip up 1 card if it's not empty. Or according to the draw stock config, you can also draw 3. And then move a card from anywhere to a foundation. So we take the top card from the source, flip up a card that's included in this function. If it's drawing from a Tableau, it knows to flip up a card. If it exposes the top card, and then put it into the foundation, and then Tableau, from Tableau to Tableau. Yeah. Take a stack. Take top card is different from foundation. You can move a stack from your going Tableau to Tableau. Fun stuff. Fun stuff. Restrict. It's just so. You win! Yay! Alright. Well, I didn't really get any work done today other than what I actually wanted to do, which was to write down the project architecture, which is still a win because the fact that this document exists means that I can come back to this another time. And that's a big W. I struggle with that when I haven't written down my thoughts and like the plan. So yeah, I'm attacking my future self with knowledge. I'm gonna stop streaming and go play video games with my friends. What time is it? 4 o'clock. Oh, that's actually good timing. We're gonna start at 6 p.m. We're gonna play Abiotic Factor. I'm excited. Freaking love that game. Yeah. Thank you so much for talking to me about this. Like this, I love streaming because of people asking questions like that. You can just set me off, and it's so fun to talk about my projects and Rust. I'm obsessed with Rust now. I knew it would happen because like Rust is sort of cultish, where you have to glaze Rust. Everyone glaze Rust. All praise Rust. And I just knew I would become part of the Rust cult before I started learning the language. And sure enough, Rust cult. I saw you on YouTube, watch you do engine work. Write a Rust game engine. Mostly everyone does C++ and C. It's the well, depending on the trade-offs, it's the smarter choice, has a much more mature ecosystem. If you're trying to get something done as fast as possible, I guess probably you shouldn't write your own game engine. You should use an off-the-shelf game engine and just like throw your stuff together. But yeah, if you care about the same things that I care about, consider Rust. Consider C++ as well. Although, consider it a lot less. Consider it less. C++ is the enemy. Okay. Goodbye. I'll probably stream again tomorrow, and I don't know what I'll work on. I should probably figure that out. Otherwise, I'll do a lot less. But yeah, see ya. Bye.